Hello everyone, welcome to a new video. This video we are going to cover the topic of NIOS Senior Secondary Maths, chapter is sets, and in that already we have covered some topics. You can go and check it in the playlist. Today we are going to cover the topic of interval as subset, types of interval and the power set. Before beginning, I would like you to subscribe to the channel so that you get all the notification on time. So we are going to start with the topic 1.4.2 from the chapter sets, interval as subsets of real number. So what is an interval? An interval I is a subset of R. So real number, this is interval such that if x comma y belongs to this interval, then z is any real number between x and y, then we say that the z also belongs to this particular interval. In simpler words, this is one definition. Forget the variables that you have used here, x, y and z. This is another example of x, y and z. So here you can see whenever y is in the middle of x and z, like x is less than y and y is less than x, if this is the condition and x comma z belongs to this interval, we say that y also is a member of or belongs to this particular interval. This is what the condition that is being told here in words, and this is the notation. Now different types of intervals are there. Let's see one by one what they are. So we have got finite interval and infinite interval. Usually finite interval we will have definite number of integers that are being used. Here indefinite means you will have the usage of infinity. Let's see what are they. So first one is the set x belongs to R, real number, where a and b are there and x is something in between a and b. We call it as open interval and it is denoted by this bracket, and the example would be like this: a to b. So your number x lies anywhere between this. So what do you understand by this open? It means excluded and b is also excluded. In between whatever exists, that will be the values. Next option is closed interval, or type is closed interval. So in this case we say this is the condition that is being followed. So a and b, we also use less than equal to, and here also you can see less than equal to is used. So in this case this kind of notation is used so that a comma b, and this is a closed interval. That means this a is also included, b is also included, as you can see in this case. Okay, so this is what the interval says. A and b has to be included. In this one, a and b is not included. Less than that and more than this and less than this values are included. Okay, so these are the two intervals that we have seen. We are going to see next types. Next, this one, if you see the diagram of this one, closed interval, you can see a is included, b is also included. Okay, this shows, this colored circle shows you that. Next one is open on left and closed on the right. That means a has not to be included, but b can be included. B is included. So see here, we are using here less than equal to, and here it is lesser symbol is used. So that means A will not be included, whereas B will be included. So in the notation itself, it is clear. This is an empty circle without a coloring. Here it is colored circle. So B is included, A is not included. Okay. This is another type. Again, it comes under finite interval. Next interval is closed on the left and open on the right. Similar to the previous one, just the opposite. A is included, B is not included. You can see from the here from the symbol what it is given. A is included and B is not included. Okay. Next one. These four are finite intervals where you are using exact numbers for the interval. Next comes infinite, where infinity symbol is used. Now if you see here, x is lesser than a. So one point is given as a but not included, and it goes till infinity. So this will be the case. A is not included, that's why this kind of bracket is used. And the other side also we don't know, because since it is infinite. Okay. Next one is included one. So similar case, but A is included. So that's why the circle changes to darkened one. So A is there this time. So the type of bracket also changes here. You can see here it is this kind of bracket and this is square bracket. Okay. The other side remains the same. Next comes the case of positive A. That means more than this A. See here, more than this A, but A is not included. So A is not included and it goes to infinity on the right. And similar way, when A is also included, the other one is included one, A. You can see from here, if it is included, put a greater than equal to. Okay. From the diagram, it is clear. So these last four, where you are using this infinite symbol, we call it as infinite interval. The other four, the first four were finite intervals. Okay, so these are the different types of intervals that are to be used. And first four intervals are called finite, the other are called infinite intervals. And if you see, length of each of the four intervals are like this. This is the length. Okay, we call this as the length of the interval. Whereas for the infinite one, length is not mentioned, since it goes till infinity. So hope you understood this one. Let's go to the next topic, that is power set. Power set, it means set of all the subsets. Set of all the subsets is known as power set. Okay, let's see how it is done. So if you take this set A with A and B as the elements, so its subset will be one empty set and the set original set. Okay, then individually A and individually B. So four subsets are possible for this particular A set. Why it is 4? Because 2 raised to 2 elements are available. 2 raised to 2, it is 4. So you will have 4 elements as the subsets. Okay. Now set of all these subsets are known as power set. Now B is another set which contains the empty set, the original set, A set and B set. So everything together again as a set is known as power set. This is the definition of your power set. Hope you understood. If you got doubt, please do comment in the comment section. And it is denoted by P of A, power set of A. Let's check two questions that are given here. Write the power set of each of the following sets. So this is the set that we have to find out. So first question says x a is a set of elements where x belongs to R, okay, and x square plus 7 is equal to 0. So these are the two conditions. Let's solve it and see what we get. So your set A will contain the elements that satisfy these two conditions. So x square plus 7 is equal to 0, which implies x square is equal to minus of 7. And then x is equal to square root of minus 7, plus or minus square root of minus 7, which is an imaginary number. This is not a real number. So in this case, you won't get any elements for x. That is, the set A will contain only disjoint element, that is empty set. It is an empty set. So for this empty set, what will be the power set? It will be subset of that empty set. So this will be the answer for the first question. Let's check the second question now. Question says B set contains y element where y belongs to natural number, and condition is given like this: 1 less than equal to y less than equal to 3. This is the given condition. Let's check out how to do this. This is the given condition. First condition is y belongs to natural number, and second condition is given here. That means 1 is less than equal to, so 1 is also included, then comes 2, then comes 3. So these three elements are there in the set B. Now what will be the total number of subsets for this particular set? Let's check. Number of subsets will be 2 raised to 3 elements because of this 1, 2, 3 elements. Answer is 8. So you will get total of 8 subsets. So how to find them? First one will be the empty set. Second one will be the original set 1, 2 and 3. All the elements included. Then comes individually 1, 2 and 3 as the elements. Then comes combination of 2 elements and 1, 3. If you check in total 1, 2, 3, 4, 5, 6, 7, 8. We have got 8 elements as the subsets. Then the set of all these elements are known as power set of B. So that is the output of that particular question. Next question is example 1.12. Write each of the following sets as intervals. So here the first question is given: x belongs to R and x minus 1 less than x less than equal to 2. So this is the given condition. You have to express it in the form of interval. Okay. So first option is this one. In this one, the elements are the question has a condition that has to be solved first. So here if you see, you have an inequality 1 greater than 2x minus 3 greater than equal to 0. So first solve for the x. Here in this case it will be 1 plus 3, 2x greater than equal to 0 plus 3. It will become 4 greater than 2x greater than 3. Then comes dividing, that is 4 by 2 greater than equal to x greater than equal to 3 by 2. This 4 by 2 becomes 2. So 2 greater than equal to x greater than equal to 3 by 2. In both the cases, both are included because of this equal to sign, and the interval becomes like this: 3 by 2 comma 2, both included with square bracket. If you see 3 by 2 is the smaller number, so start with that and goes till 2. So this is the answer for this particular question. Interval is this one, square bracket 3 by 2 comma 2, which implies both are included. Next topic is universal set. Universal set example, if you see, first one is A. A is X, where X is student of your school. So all the students of your school are there. B contains Y is a male student. C contains female student of your school. And D says A is student of class 12th in your school. So any of the options you take, B, C or D, it belongs to this A. A is the main set. So A is the main set. That main set is known as universal set, where other subsets like B, C and D, everything comes inside this A set. So we call that as universal set, and usually it is denoted by U symbol. The particular problem is set U is said to be universal set if all the sets in that problem are subsets of the universal set. Let's note, universal does not mean a set containing all the objects of the universe. A set which is a universal set for one problem may not be the universal set for another problem. This is an example given. Example, which of the following sets can be considered as a universal set? This is the example. X is a real number, Y is a negative number, then Z is a natural number. Negative number and natural number comes inside real number. So real number would be an universal set, and these are the subsets of X. So X is the universal set for this problem. Understood the topic discussed in this video. If you have got doubts, please do comment in the comment section and give a thumbs up if you like the content and found it useful for your exams. Share it with your friends and don't forget to subscribe to the channel so that to get the notification as early as possible. Thank you for watching.